6.5, inverses of matrices. The first thing that we have to remember is in order to have an inverse, we have to have what we call an identity. And we don't actually really get into a lot of stuff with that. It's in math what we call group theory when we do a lot with inverses and identities. But the identity in regular terms, we have a multiplicative identity, which would be 3 times 1 equals 3. This is the identity. In addition, it would be 3 plus 0 equals 3. Okay, in matrix multiplication, the identity, we call it the identity matrix. We use the letter I for it. We have some matrix that is always square, which means that it has to be like a 2 by 2 or a 3 by 3. It can be huge, it could be 100 by 100, but there's always diagonals everywhere on the diagonal. There's always ones on the diagonal. And zeros everywhere else. So we could have like lots of dot, dot, dots. So zeros everywhere else, dot, dot, dot. Okay, but this whole line has to be ones. The diagonal is ones. Is all ones. Everything else is zeros. That's a terrible else. If I were given some matrix A that's like a 2 by 2, I could multiply that by matrix I, which would also have to be a 2 by 2. And if I asked you for the identity matrix that was a 2 by 2, you would just automatically know that I that is a 2 by 2 is just 1, 0, 0, 1. If it was a 3 by 3, so it was whatever the I is going to depend on how big this one is, just as long as it's square. So if I gave you some matrix A times the identity, I would always get matrix A back. And this is with matrix multiplication. And then if I took I times that same matrix, I would get the same matrix. It doesn't matter which side I multiply the inverses on. And if you remember in our other multiplication, we didn't even always get the same size of matrix. So we couldn't have the same thing. So this is one of very few things that actually get you the same output over here. Okay, and so let's try, we're going to find those inverses. We're going to go ahead and multiply them and just check through them real fast. So I'm going to give you matrix A is equal to 4, -7, -3, 2. And since this is a 2 by 2, my I is equal to 1, 0, 0, 1. And you sound like you're speaking like Bender from Futurama when you say those. So now I'm going to multiply. So A times I is going to give me a 2 by 2 matrix. So I'm going to make my 2 by 2 little spots. Okay, I'm going to have 4 times 1 plus -7 times 0. Then I'm going to have 4 times 0 plus -7 times 1. Then I'm on this bottom left, I'm going to have -3 times 1 plus 2 times 0. Then over here, I will have -3 times 0 plus 2 times 1. When I do that, I will just get 4, -7, -3, and 2, which is the same thing. It's not going to matter either direction. Also, if I took I times A, I will get this same thing. Okay, you should know any time that you multiply by the I, you will get the same as your old one. So you don't actually have to go through all those steps sometimes when you see an I. So we will just write like AI equals A. We've already kind of done this, and IA equals A. So those are nice little notes to remember. And then we also have what we call the actual inverse. So we've been talking about the inverse, or we've been talking about the identity, I'm sorry. Now we're going to talk about the inverse. The inverse of a matrix is written like this. It looks like A to the power of -1, but we read it as A inverse. Inverse. So if I see A to the -1, or if I say A inverse, I want you to write A to the -1. What this means is just like, it's kind of like when we add 3, what do we have to add to that to make it equal 0? We have to add -3. -3 is the inverse of 3. That's what we're doing. We're trying to get to the identity, but this is the identity in addition. 0 is the identity in addition. However, in matrix multiplication, the I is the identity. So what we want is we want to have A times A inverse, and we want it to give us the matrix I. And we have to be able to do it both directions in order for it to be the inverse, which means that I also have to be able to multiply as A inverse A equals I. So you will have to check it both directions when we do that. In order to find that inverse, so basically what happens is when I want to solve a big equation, and we'll do it later on, we will use these to solve systems of equations in just a couple seconds, but right now we're just going to show that something are inverses. So if I give you A is equal to -2, 3, -3, 4, and B equals 4, -3, 3, -2. And if you notice, what always happens with matrices that are inverses is they look very, very similar to each other. Sometimes they're off by a couple numbers or like a factor of a number, so like off by a multiple of it. So what we have to do is take A times B. So I'm going to go ahead and write it out. So I'll have -2, 3, -3, 4, 4, -3, 3, -2. And then we're also going to have to do it as B times A. So I'm going to have -2 times 4 plus 3 times 3. And then I'll have -2 times -3 plus 3 times -2. Then I'll have -3 times 4 plus 4 times 3. And then on the bottom right, I'll have -3 times 3 plus 4 times -2. Okay, so 2 times 4 will give me -8 plus 9. Cool, that's 1. -3, that's going to be +6. This will be -6. That's a 0. Good. A positive and a negative of these guys will give me 0. This will be -9. And this will be, oh, that's a -3 and a -3. So it'll be a +9 and a -8, which will be 1. Okay, so that direction worked. So then you'll also have to check B times A. So I have 4, -3, 3, -2, -2, 3, -3, 4. And I believe all your calculators should do matrix multiplication, so you guys can go ahead and start using that as well. Just remember that you will have to show your steps on the test, so if you need practice, take that time to do the practicing of it. Okay, and when I multiply this direction, I will also get 1, 0, 0, 1. So B and A are inverses of each other. Okay, so we could write it as B is equal to A inverse, or that A is equal to B inverse. Either one of those would be right. Okay, so they're also what we're going to do is take a matrix, the one that we already know, and we're going to just plug it in our calculator to find the inverses, because really you will never actually, maybe when you actually, if you ever have to take linear algebra, you will do this. But basically, we're just going to take our calculator, we're going to go find that, we're going to go type in our matrix that we're given. In order to find our inverse, we go over to Edit. I want to do a 2 by 2 matrix, and my numbers are -2, 3, -3, 4. I'm going to get out of here. I'm going to go pick that matrix that I was just typing. So I was typing in A, so I hit A. And then I'm going to hit this X inverse. What that's going to do is tell me that A inverse equals this guy. So A inverse, now I'm going to write on this, A inverse equals this guy. Okay, that was the same one that we already given. We already tested that. Sometimes it'll tell you that things, I'm not sure exactly the message that it tells you, but if it tells you some sort of error message, means that there's no inverse. No inverse if there's an error on your calculator. Then when let's just test typing in a larger one. So I can go to matrix, my matrix menu. I go over to Edit. I'm going to do a 3 by 3 matrix. And so just for example, let's do 1, 2, -1, 3, whoops, yep, 3, 5, 3, 2, 4, 3. Enter. Okay, so I'm going to quit out of there. And basically, I can do the same thing because it actually thinks I'm typing in the same matrix. So it gives me this as my inverse. You can also make it do fractions for you. So I'm going to do second entry, which will just repeat whatever I was doing. And I'm going to go to Math and Fraction. And it will give it to you in fractions. These are now equivalent fractions, or these are equivalent matrices. And they are, the inverse is of the first one that I typed in, which was A equals 1, 2, -1, 3, 5, 3, 2, 4, 3. And if you wanted to test in your calculator, you could also see that when you multiply them, I could take A inverse, I'm going to get rid of my little fraction sign, and I could take that times matrix A. And I know I should get my identity matrix, which this guy right here, 1.4 times e to the negative, this basically means that it's a very, very, very tiny number that is 0. So these actually are, there's just a problem with how it does some fractions and decimals because it rounds somewhere in there. And so it doesn't get quite to 0. But that is what it actually would be if we did it out by hand. Okay, we've already used like row reduced echelon form to solve a system of equations. The other way that we can actually do it is if I have some matrix times my variable matrix equals another matrix. So yesterday you were having to write out, I'll give you an example of what an AXB thing would look like. If you were given this system of equations, -x plus y equals 3, and then I had 5x minus 4y equals 16. This would look something like if you had to make an equation equivalent to the system of equations, you would write your coefficients in a matrix, which would be -1, 1, 5, -4. And then I make my variable matrix. In this case, it's just x and y. And then I make my answers over on the other side, 316. Whoops. Okay, so that's how you would make the matrix equivalent to the system of equations. And so A is your coefficient matrix. A is X just represents your variables. And B is equal to your constants. I'm just going to write constants. And so basically I have to have them set up all in the same order. So I have to have my x, y's, and my numbers on the other side of the equal sign. Same kind of rules we've been doing with it. Now in order to do this, so I'm just going to take this AXB for example. If I just had you solve a really old, like when we were just doing linear things, if I had AX equals B and I asked you to solve for x, what you would do is divide by A. The reason we divide is because division is the inverse of multiplication. These were multiplying together. Now, instead of dividing, because I can no longer divide with matrices, no such thing exists, I multiply both sides by the inverse. Now the tricky thing is that I have to multiply on same side. Okay, so I cannot, so this A inverse times A will give me the identity times my variable matrix, and that will be equal to A inverse times B. Okay, but remember that if I multiply things on different sides, I don't get the same answer, so I cannot, it is not equal to B times A inverse. Sometimes it may be, there might be some exceptions, but generally do not assume that it's true. The identity times anything is just what that identity is. So x is going to be then equal to my inverse times my constants. So in order to actually solve this system of equations, what I'm going to do is I'm going to make this system, or I'm going to write this matrix equivalent out for it, and then I'm going to find the inverse of it. So then in your calculator, so my A, I'm going to write out A equals to negative 115, negative 4. And I do this because a lot of the work really is done in the calculator. So it's really nice to just have a list to say, no, I know that this is what I typed in. And that way you can go back and check to see if you did not type something in right, then you know where the problem is. So I had 3 and 16 there. So what I'm going to do is I'm going to find A inverse. So I'm going to use my calculator. I'm going to type in this matrix. So I'm going to go to my matrix menu. I edit, enter. I have a 2 by 2 matrix. And then I'll have negative 1, 1, 5, negative 4. Oops, negative. Then I'm going to quit out of this menu. I'm going to go find my inverse. So I go to matrix and then I hit my little X inverse key. Enters and I get 4151. 4151. Okay, and I just write that down so that I know I have it. And then in my calculator, I'm going to go make a matrix B in here, and it's going to be that same one, and I can name them whatever I have. Just make sure you keep track of what letters you actually name them. Okay, so B is going to be a 2 by 1. Okay, as soon as you hit enter, it automatically sizes it. I have 3, enter, 16, enter. And then I quit out of there. And then I'm going to take matrix A inverse times matrix B. The reason why I find matrix A first, or A inverse, is to make sure that it exists. So if there's a problem, I know exactly where it is. And so then I will get X, or basically I will have XY equals 38 or 28 and 31. 28 and 31. And that tells you real fast that x is equal to 28 and y is equal to 31. So this is very useful, and this is a way that we can solve the systems of equations real fast. Even if we don't have that RREF form in our calculator, we can still use matrices to solve those. Okay, I want you to do a lot of problems for these ones, but I'm okay with you guys pretty well using your calculator. The homework is on page 530. I want you to do numbers 1 through 50. For the most part, you can use your calculator. I want you to do like one in each section by hand. For numbers 5, you don't have to write this down. For numbers 5 through 24, it says use the Gauss-Jordan method. I'm not worried about that. Just use your calculator. So use calculator. Can't spell calculator. You got it.